Mm, okay, hello everyone. It's Salar and we are in part 43 of our tutorial to writing a real-time operating system. In previous parts, I've implemented a simple RTOS that just does context switch by using of tick timer, and I've implemented some data structure that I want to use in my operating system. Okay, now after these parts, in this part 43, I want to finally talk about real-time operating system. A real-time operating system that is complete with more options, okay? Not just a real-time operating system that just supports context switch. Okay, so let's go to develop our real-time operating system, RTOS. But as I said, and as you saw in simple RTOS that I implemented some parts ago, I've implemented an RTOS that just support context switch. Okay, that was a simple RTOS that just support context switch. What's context switch? As I said, when you have some threads or process, for example thread 1, thread 2 to thread n. Okay, thread 1, thread 2 to thread n, changing, running from one thread to another thread when you have tick timer interrupt in a constant time slice. Okay, for example in 1 millisecond. Okay, this is context switch. But a real-time operating system, complete real-time operating system must support priority. Priority. Okay, but what's priority? I want to talk about a structure of running threads and priority in a real-time operating system. Okay, I want to say what is priority in a real-time operating system. Let's see this example another time. We saw this example in simple RTOS implementation. Okay. Another time, assume that you have a car and in the computer of your car there is a microcontroller unit. Okay, you have an MCU in your car, and this MCU must do some jobs in 4 threads. Must do 4 jobs in 4 threads or 4 processes. In thread 1, check the heat of engine. Okay, check the heat of your engine. In another thread, read and show the speed of your car. In thread 3, show you how much fuel you have in your tank of your car. Okay, and for example in thread 4 you have a crucial thread that must control your ABS brake in your car. Okay, and when you push your brake in your car, immediately your microcontroller run the thread. Okay, here is more prior thread than other threads. Okay, and thread with higher priority, for example T4 has higher priority than other threads. Okay, can preempt a stop running of other threads, preempt a thread with lower priority. For example, when your microcontroller running thread 3 and suddenly you push your brake in your car. Okay, in this time microcontroller must stop running of the thread. Okay, and immediately jump to the thread, preempt thread 3. Okay, here is behavior of priority. But how we can how we can implement priority in our real-time operating system. In my real-time operating system, I have 8 levels of priority from 0 to 7. 7 is highest priority. ISR, interrupt service routine, like interrupt service routine, is not running an interrupt. Here is just a name. And ISR means this is the highest priority, and idle priority, okay, is the lowest priority. But you can create your thread by using a priority 1 to 7. You can't create a thread with this priority. Before starting your operating system, real-time operating system, create an idle thread by this priority, just one thread, this thread, okay, and your operating system automatically create the thread before it starts running up your real-time operating system. And when no other thread with other priorities are running, when you have no other running thread with these priorities, okay, when you have no other thread with priority from 1 to 7, your operating system runs this idle thread and do some things, okay. I will talk about idle threads and other things in next slides, okay. But you can create your thread by one of these priorities: low, normal, normal, above normal, high, real time, and ISR. Highest priority and lowest priority, okay. Here is an array of pointer, okay, array of pointer. Here is array of pointer, and each of these pointer point to a circular queue, okay. Each of these pointer from 7 to 1 point to a circular queue. And for example, when you create a thread that its priority is ISR, the real-time operating system puts the thread in the circular queue. Or for example, when you create a thread that its priority is above normal, your operating system puts in another circular queue, okay. But in RTOS, RTOS runs just the ready list or ready queue, okay. Each of these queues called a ready list, okay. For example, ready list of ISR, ready list of above normal, ready list of high, and so on, okay. RTOS runs just the ready list or ready queue that has higher priority, okay. For example, when you have two threads that has priority high, for example, thread 1 and thread 2, and you have two other threads, thread 3 and thread 4, that has priority normal, and two other threads, for example, thread 5 and thread 6, that have priority low, your real-time operating system just runs these two threads, okay, because these two threads has higher priority than other priorities in a circular queue, one by one in a row, okay. Run T1, after that run T2, after that another time run T1, okay, in a row. And your real-time operating system doesn't run other threads with lower priority, okay. So here is here is structural ready lists in our real-time operating system. In our real-time operating sorry in our real-time operating system, we have some levels of priority, and you can create your thread with one of these priorities. For example, you can create your thread by priority high or normal or other priorities, okay, except priority idle. Okay, you can't create your thread by priority idle. You must you mustn't create your priority with priority idle, okay, because your real-time operating system create just one thread with this priority, okay, and has some usages, okay. But let's see an example in Eclipse in my operating system and see the behavior of priority and preemption in my real-time operating system, okay. Okay, here is a simple example, but don't worry what if thread create new thread, what is this functions of this system calls, or what is this types. And here is my operating system, okay, this is my operating system, real-time operating system. But in next parts I will talk about all part of my operating system, but I want to just in this part I want just talk about priority, okay, create some threads with different priorities and see the behavior of real-time operating system, okay. But I've added this header file to my code to use my real-time operating system. I want to create 6 threads from thread 1 to thread 6. For each thread I have a function, okay, thread function, okay, and I will say you what's parameter in a thread function, okay. Here is not important. Here I have 6 function, one for each of these threads. Here is implementation of function. In each function I have a bodiless while loop, okay, infinite while loop, and here is my main function. Before to using your real-time operating system, you need to initialize real-time operating system by this function, and after that when you want to create a thread you can use this function. Don't worry, I will talk about the structure of real-time operating system and all of these functions and system calls, okay. Now I want to just talk about priority, behavior of real-time operating system, okay. Here is thread 1, here is name of thread 1, here is function, thread function of thread 1, here is not important at this moment, and here is priority of thread 1, okay, priority high. And thread 2 has another time priority high, but thread 3 and thread 4 has have priority normal, and 5 and 6 have priority low, okay. Now let's run this code and see the behavior. Okay, I'm in debug perspective. Let's run my code. First initialize operating system and create all of threads. Now all threads are created, and now I want to start RTOS and jump to thread functions. I have one breakpoint in each of my functions, thread functions, okay, but because the priority of thread 1 and thread 2 is high, your operating system just run these 2 threads. But because thread 1 inserted before thread 2, first your operating system must run thread 1. So let's run the code. Okay, operating system is in thread 1 function, thread function 1. But remove breakpoint from here and another time run. Jump to function 2 because function 2 like thread 2 like thread 1 has priority high. Okay, another time remove breakpoint here, put a breakpoint here and run another time jump to function 1, not other functions, because the real-time operating system just runs these two functions, these two threads. As I said, when you have, for example, in high thread 1 and thread 2, your real-time operating system first run thread 1 after thread 2, after that back to thread 1, and for example doesn't run thread 3 and thread 4 or thread 5 and thread 6. Okay, RTOS runs just the ready list that has higher priority. Okay, so for supporting priority, I need to implement this structure in my real-time operating system. We will return to this structure in next parts and implement this structure in our real-time operating system. But this part just was the behavior of real-time operating system that supports priority. Okay, so here was an example. Here was some system calls, for example in this time create new threads and other functions. Okay, in next part I will start to talk about system call in a real-time operating system. Okay, thank you very much to see me and see you soon in the next part. Thank you very much.